Okay, let's explore our dataset a little bit more. The very first thing that I want to do is to print this few observations in a nicer format. With the previous command that we just had, print iris data, what happened was that Python printed the first 5 and the last 5 of our observations, but it's not in a very nice format. So in order to have a general overview of what our data set looks like, we can just type in iris underscore data dot head. Iris underscore data, remember that is the name of our data set, and then the head is going to just print the first 5 observations in a very nicely formatted way for you. So it's much easier to look at the data and see, what are the different variables that you have in your data. The other thing that you can do is to have some general information about your data set, and that is with the .info command. So you just type in, again, the name of your data set, iris underscore data, and then .info, and when you run it, Python is going to give you an overview of the data set that you have. In this particular case, you see that it says it has 150 entries. It's basically 150 observations ranging from 0 to 149. This is the ID of the observations. And then it tells you that there are 6 columns in your data set, and these are the names of the columns and the type of the columns. So, for example, sepal length in centimeters is a float 64 data type, whereas a species is an object data file. It basically means that it is not a numeric in this particular case. We will use this information momentarily when we want to transform our data set and make it ready for analytics. There are, other things. You could, for example, get the same information about data types with D types. So if you had typed in iris underscore data .d types and you run this, what you get is this. Okay, so you only get the part of the information about the data types. So you don't get this count, for example, or no null columns. You only get the information about the types of the data types of the columns that you have in your data. So these are some of the very useful commands that you should know in order to be able to do some initial exploration of your data set. However, when it comes to exploring your data, it's a picture is worth a thousand words, and basically visualization is much better. So the very first thing that you have to do if you want to visualize your data is to go ahead and import matplotlib. And in the previous videos, I showed you how to install that library. And in order to import it, you just go ahead and say import matplotlib.pyplot as PLT. And so it's just similar to the command that we had earlier. When we import something, we give it a nickname, right? So that we don't have to type in the full name throughout our code. So here, the pyplot from matplotlib library is going to be known as PLT further in our code. So we don't need to call it all the time. And then one other thing that you can do is to import another library, which is called seaborn. So you can just say import seaborn as SNS. And just like pandas that sits on top of NumPy, here seaborn sits on top of matplotlib. Right? So with that, you can do a lot of enhanced visualizations. Now, before I show you how to create a simple chart with matplotlib or seaborn, I'm going to give you one additional trick, which is this command, the %, and then you type in matplotlib space inline. And what this does is that it tells Python that you want the charts to be shown within the same page, right? You don't want them to be shown in a new window, right? So you put this, and then it's much easier to deal with your visualization. So now what I want to do here is to visually explore my data set. And because, the object of this example is to see how we can use these features, which are the length and width of sepal and petal, to classify them. One thing that you can do is to just create a two-dimensional scatter plot, right? Based on, say, sepal length and width, and see if you can visually detect any differences among different species based on only those two features. So it's very easy to do that. You can do that with lmplot in seaborn. So what you're going to do is to type in sns.lmplot, and then you have to identify basically your x and y, right? What is going to be on your x-axis, your horizontal axis, and what's going to be on your y-axis, which is the vertical axis. So let's say that we want to plot the sepal length to be on our x-axis. So I just say x is our sepal length, and then you have to put in a comma, say y is our. And then one thing that I recommend that you do is that whenever you want to type in the name of the variable, it's better just to copy it from the printout, so that you make sure that you do not have any typos. So we have the sepal length against sepal width, and then you have to specify the source of this data. So basically where seaborn should go and look for these two variables, and these two variables are in a data set called iris data. And now what I want to do is to create different color coding for different observations, right, based on their species. So that is with the hue option. So I say hue is equal to species, and again, I'm going to copy it from here so that I make sure that I'm not going to make any typos. And one other option that I'm going to put here is that I say fit_reg is equal to false. And what it does is basically tells Python that I don't want any regression lines to be fitted to my data. And let's run this and see what we are going. Okay, let's see what we have here. Okay, I made a mistake here, a typo here, and I forgot to put the LM plot. All right. Okay, let me see what's going on here. So it is LM plot, PLOT, sorry. Yeah, again, I made a mistake in typing it. And then this is what you get. You can see that you have three types of species: Setosa, versicolor, and virginica. And based on just the width and length of sepal, you can see that it looks like there are the three categories, right? So the blue one, which is Iris setosa, looks like that it is all scattered together to the left of the plot, whereas the other two are kind of together, with the exception that this Iris virginica seems to be more, concentrated toward the right, meaning that their sepals are larger, and also they're, both in terms of length and width. So just by looking at this, it seems like, these features are good things, good classifiers for you. You can use these features, to go ahead and classify these iris into different species. Now, before I end this video, I just want to show you that, with the seaborn library, you have a lot of possibilities when it comes to data visualization. And depending on what your purpose is and what type of data you have, you can use many different visualization types. And if you go to seaborn.pydata.org, and click on gallery, you would see a lot of different types of data visualization possibilities, and you just click on them and it gives you the code. So you would become much more comfortable in using different data visualizations type as you become more proficient with machine learning in Python, and when you're dealing with different types of data. And the best way to learn how to create these visualization is through practice. Whenever you're facing a new data set, think about what is the best way to visualize it, and then you can come here and try to basically copy these code pieces and then adjust them so that they will fit your particular application.